Ladies and gentlemen, welcome to my second PowerPoint tutorial in which we shall deal with animation. I'm going to demonstrate how you can make a pair of scissors cut, how you can make an engine run, and even how a heart can be made beating. Now, there are three different techniques that I use when I want to add movement to my illustrations. So, technique number 1. Use the conventional animation tools that are present in PowerPoint. Now, I once needed to make an animated illustration of a kidney transplantation. A kidney is usually transplanted to the groin of the recipient, and the blood vessels of the kidney are there connected to the iliac artery and vein. To make these connections, the anastomosis, you'll need to apply vascular clamps to the vessels, or else the patient will bleed to death as the necessary holes are made in the vessels. Now, in order to move these clamps in and out of the illustration, I simply use the ordinary animation tools that comes with the program. I've here imported these three items into the 2010 Windows version of PowerPoint. To add animation to one of the vascular clamps, you just mark out the item by clicking upon it, then selecting the Animations menu and choosing from the many animation options present either in the main menu or in the expanded menu at the bottom. I frequently choose either spiral in or boomerang, as they are both working quite nicely. To add a second animation to the same object, select the object once more, then click Add Animation and select a new thing that you want to happen. To some animations there are effect options. In this case you may choose the direction of the fly out exit. An overview of the added animations may be seen in the Animations pane. To add the same set of animations to another item, select the object to which the animations has already been added, then select the animation painter before you just click upon the next object that you want to have the same animation set. The sequence of the animations may thereafter be rearranged in the Animations pane. Some will probably ask, how do you open the vascular clamps so as to get the blood vessels in between their branches? Well, the answer is, I don't. I'm actually cheating. I make a notch for the vessels on one of the branches of the clamp so as to make it look like it is passing behind the vessel, and the same goes for the other vascular clamps. Now, adding movement to the vascular clamps is rather straightforward, and so is the entrance and motion of a surgical knife. Making a pair of scissors cut, however, is a bit more challenging. First, the scissors needs to be composed of two separate images imposed on top of each other. Next, you can't just add a slight rotation in opposing direction to each of the images. Unless you know exactly what you're doing, the result may look stupid. The problem is you need the images to rotate around the screw connecting the pair of scissors, while in PowerPoint rotation is always around the center of an image. The images in this instance therefore need to be enlarged in two directions so as to bring the connecting screw to the midpoint of the images. Any rotation now added will have the connecting screw as the point around which the image revolves, and so the animation is now working as intended. Let's go quickly through the addition of this animation step by step. Here we see the two images already imported in PowerPoint. Now select any one of them and go to the Animations menus, and there eventually find and select an animation called Spin. Next, open the Animation pane and customize the effect settings and the timing of the spin. About 20 degrees of rotation will probably do. Then select counterclockwise for this particular branch of the scissors. Third, the effect needs to be auto reverse. Then go to timing. A little more speed is probably needed. And then, if you like, you may select the motion to continue until the end of the slide. Next, use the animation painter to add the very same animation to the other image. Just remember to invert the spin direction thereafter so as to give the scissors opposing movement. Next, make the two actions simultaneous by selecting Start with Previous for the latter animation. Finally, drop the frontmost image on top of the other one, and your animation is ready. Now, back to the kidney transplant animation. Clamps are first applied to the iliac vein, which is then opened and an anastomosis made between it and the kidney vein. The clamps on the iliac vein are then replaced by one on the kidney vein before different clamps are applied to the iliac artery. An incision is next made by knife and then elongated by scissors. Now, movement for the vascular scissors is made in pretty much the same manner as just demonstrated for an ordinary pair of scissors, except that only the scissor branch entered into the lumen of the vessel is moved so that it lifts the vessel wall a little and thereby ensures a clean cut. Well, that's all about transplantation for now. I intend later on to upload the entire kidney transplant animation as a separate video. Now, how about making a running two-stroke piston engine? Well, to make such an animation you certainly need to make a separate drawing for each of the moving parts of the engine. Then, for the piston, you simply add movement up and down, and for the crank you add rotation. The tricky part is the piston shaft, which requires a rather complex motion. First, it should have a pendulating movement. The pendulation, however, is actually just rotation around this point, which means the image has to be drawn with this very point as the midpoint, just as I earlier described for the scissors. In similar manner, this point also needs to be the center of the crank drawing as explained in an earlier video of mine. Next, the piston shaft should have motion up and down, but the two movements need to be properly coordinated or the animation won't work. Now, if we put these four drawings on top of each other, we do get a quite nice animation. A spark from the ignition plug may even be added, and if a separate semi-transparent drawing of the front wall of the engine block is finally added, I think this animation becomes pretty cool. Now we'll have a more detailed look at the making of this engine animation. First, the engine block is imported. Next, the piston drawing is also imported. This drawing, however, needs to be made transparent for the animation to work. Downward movement is then added to the piston. Well, that seemed to be a little bit too much, so we may shorten it a little bit down, maybe like this. Then let's go to the animation pane to customize the settings for effect and timing. For the effect, choose Auto Reverse as you want the piston to move up and down. Then for the timing, 2 seconds is too much, the animation will be too slow, so let's change it to 0.2 seconds, and then it should be repeated either until next click or until the end of the slide. That looks pretty cool. The crank of the engine is the next image to be imported. And the background will need to be made transparent for that image also. Now we see that the crank appears to be too large for the engine. This is because PowerPoint has automatically resized the engine block drawing and the piston drawing to make them fit into the slide, whereas the smaller crank drawing never needed resizing to fit into the slide. Now, if we look at the size attributes of the piston drawing, we see that it has been sized down to 83% of its original size. What we do therefore is to downsize the crank image also to 83% and everything will be fine. Now the image is brought to the middle of the crank house. Next, spin is added to the crank image. Then the effects settings and the timing needs to be customized just as we did for the piston drawing. In this case, a full rotation clockwise, already selected by default, is actually what we want. Then we need the animation to start with the previous one. The timing must be coordinated with that of the piston, which was 0.2 seconds for the downward movement and another 0.2 seconds for the upward movement, which means the timing for a full rotation of the crank must be 0.4 seconds. And finally, this movement must also last until the end of the slide. Next, the piston shaft is imported. And then the background of that image also made transparent. Now I'll save you some trouble by telling you that bitmap images cannot be made transparent if you have an older version of PowerPoint. So, in that case, it may be wise to save the drawings in the TIFF format or in the PNG format. The piston shaft is next downsized to 83% of its original size and then tilted 14 degrees counterclockwise. The piston shaft is next moved into position and movement down is then added. The distance of this movement is then resized. Now it is absolutely necessary that the length of the movement up and down for the piston shaft equals that of the piston. Likewise, the time and effects settings must also be the same. Next, rotation is also added to this image. Then, in the effect setting box, select 28 degrees of clockwise rotation. Now you need to press the tab button to get out of there. Then remember to select auto reverse. Now go to the timing box, choose start with previous, then a delayed onset of this animation of 0.1 seconds. Next, a duration of 0.2 seconds. Then, finally, repeat until the end of the slide. Now, after you've set the duration of this animation, go back to the effect box or window and select 0.1 second for a smooth start of this animation and 0.1 second for a smooth end of this animation. Now, the 0.1 second delay for the latter animation is required to get the right coordination between the different motions. Unfortunately, customized rotations such as 28 degrees cannot be made if you have the 2011 Mac version of PowerPoint. Nevertheless, once the animation has been made in the Windows version, it also runs nice and smoothly in the Mac version. Now move the piston shaft twice backward on the slide so as to bring it behind the piston drawing. Next, an explosion from the ready shape menu may be selected as a spark from the ignition plug. Now select Zoom as the animation for the ignition spark. Then the effects and timing options would be hide after animation, and for the timing start with previous but with a delay of 0.3 seconds, next a duration of 0.2 seconds, and of course, as always, until end of slide. Now, if you're the happy owner of both the Windows version and the Mac version of PowerPoint, the slide may now be imported into the Mac version, as I've done here, and there we may import a drawing of the front of the engine. If you have problems reading the menus right now, it's because I only have a Norwegian version of PowerPoint 2011 for Mac. The point is that it is quite easy in the Mac version of PowerPoint to make an image semi-transparent. Now, first select Total Transparency for the white background of the image, and then select about 20 or 30% of transparency for the rest of the image by this toolbar right here. And here we have the final animation running nice and smoothly. Now, technique number 2 for adding movement to your PowerPoint illustrations. Toggle between a number of images. Let's imagine for a minute that I was to give a lecture about the human heart, and for that lecture I wanted to make an illustration where we could actually see the heart beating. I could of course just use the grow and shrink animation found in the standard animation menu of PowerPoint. That, however, would just look stupid. I think even a beating play card heart would look better. So what I do instead is that I make 4 different drawings, each of a different part of the heartbeat cycle. The first image shows the heart while in diastole, that's just in between 2 heartbeats. The second image shows the heart in atrial systole, that's when the prechambers of the heart contracts. The third image then shows a partial ventricular systole, which means the heart is in about halfway contraction within the cycle of a heartbeat. And the fourth image shows a full ventricular systole, in other words, the maximum contraction of the heart during a heartbeat. Now, these 4 images, when displayed in sequence, will actually mimic the contraction of the human heart from full relaxation to full contraction. Now, in order to get the sequence of the reverse process also, the relaxation part of the heartbeat, images number 3 and number 1 are used a second time, though this time in the reverse order. Next, we just allow these 6 images to start flashing or blinking in sequence. Well, this may not look like a beating heart to you, but if we place the images on top of each other, that's what it looks like. Of course, it still isn't a beating heart, it's just an illusion, but it works. Now, let's have a brief look at the details behind this illusion. The 6 heart drawings are placed upon each other, so Only the one at the front is seen right now. The animation used for each of the drawings is the blink at the bottom of the expanded animation emphasis menu. Next, then, you need to customize the timing of this animation. Start should be after previous. Delay should be 0.1 seconds. This represents the time shift between the current image and the previous one. Then duration should be 0.8 seconds. That's how long the chosen image will be gone between two appearances. Now, why 0.8 seconds? Well, that's just something I've found out by trying and failing, that 0.8 seconds duration goes well with 0.1 seconds delay when the number of images is 6. And of course, we need to set repeat to either until next click or until the end of slide. Now I've shown the settings for the frontmost image only, but the settings for the rest of the images are identical. Now, if the toggling starts with the image at the back and then working its way forward, there will always be a slight delay in the onset of the animation as the images starts blinking one by one, and you have to get through the entire first sequence before the frontmost image starts blinking. If the toggling starts with the image at the front, however, then working its way backwards, the animation will be seen to start right away. I have in a previous video used a similar technique to make a flag move, though instead of letting the images blink automatically, I added the 4 images with the Danish flag to separate slides. And then, using my fingers on the up and down buttons to toggle between the images so as to give the flag a more random motion as I captured the show-off on video. Now that brings us to the third and last technique for adding movement to a PowerPoint presentation. Make an animated video loop. Now, to make a short video loop of a running 2-stroke engine, I started out with this illustration of a transection of an engine block, and from it I made 24 different drawings illustrating the passage of air-fuel mixture and exhaust through the engine, everything made in MS Paint using techniques described in previously uploaded videos. I've illustrated how the fuel mixture enters the crank chamber below the piston of the engine, as the crank chamber is going to act as a pressure chamber, and I've illustrated how the air-fuel mixture next travels through the scavenging port into the combustion chamber. Next, I've used an increasing red tone to illustrate compression of the air-fuel mixture. Then a spark from the ignition plug has been made on one particular drawing. Next, the air-fuel mixture has been made gradually to change from yellow to black to illustrate fuel burning in the engine, before exhaust finally escapes from it. I have here imported these 24 images into PowerPoint, just inserting them one by one into separate slides. Now the moving parts of the engine also need to be added: the crank, the piston, and the piston shaft. First, I import an image of the engine crank into slide number 1. Second, I resize it to let the size match that of the engine. Third, I give it a transparent background. Fourth, I move the crank into its proper place. A little fine-tuning is usually required there, so just select position and then do your fine-tuning. Fifth, copy the crank and paste it into the remaining 23 slides. Now 360 divided with 24 is 15. Therefore, tilt the crank image 15 degrees on the second slide, then 30 degrees on the third slide, etc. An additional 15 degrees for each slide throughout the entire series, so as to accomplish a full rotation of 360 degrees within the duration of the 24 images. Next, the piston shaft is imported, its image size adjusted, the surrounding background made transparent, and the image brought into proper position before it is copied and pasted into all the slides. The copies of the piston shaft are now slightly tilted one by one, and at the same time moved a little bit down so as to enter a position where its placement is in accordance with the crank position. The tilting angle and the vertical position used for the piston shaft in these 24 slides are as follows. Notice the beautiful mathematical symmetry of these numbers. This symmetry actually ensures a smooth movement to the piston shaft in our video loop. These numbers are critical to the connection between the crank and the piston shaft and thus essential to make our animation work correctly. For each slide in the series, I've calculated the vertical placement of the piston shaft using the tilting angle of the crank. In each position in the engine cycle, the distance between midpoint and actual position is the sinus of the angle alpha multiplied with the distance between midpoint and one of the dead points. The piston shaft images are now moved one step backwards on all the 24 slides to make the crank appear in front of the lower end of the piston shaft. The piston image is then imported, given a transparent background and correctly positioned on the first slide before it is also copied onto the remaining slides. Now the piston needs to travel the exact same downward distance as the piston shaft, but without any rotation. So for each slide, this is the vertical position calculated for the piston image. Now look at the miniatures in the left margin. As I scroll upwards, we get a pretty good idea of how this animation is going to work. So we now have 24 PowerPoint images ready for the creation of a video loop. Now you could of course make the video loop by just saving the whole series of 24 slides as a Windows Media video, but believe me, that is going to be a very slow moving two-stroke engine because PowerPoint will be dedicating too much time to each slide when the series is saved in this manner. Instead, save the slides as bitmap images for import into a video making program. Avoid saving these images as JPG files, as this may diminish the quality of the drawings and of the subsequent video loop. Next, open a video making program. I've purchased a program called iStop Motion, which is suited for making such video loops because it offers the possibility to control each video frame one by one. Similar programs also exist for the Windows operating system and for the open source code Linux system if you're using a PC and not a Mac. Now, for the current animation, it's important that we select a frame rate of 24 pictures or more. Next, import all the 24 bitmap images into the video presentation, and there we go. The simplicity of use of this program is awesome. All the images may now be seen on the timeline, and if we select the movie to be shown as a video loop, we now have an outstanding video animation of a two-stroke combustion engine. Finally, you need to export the video loop in a format that can be of use to you. If you're going to use it in a PowerPoint presentation, just make sure the video format selected may actually be opened in your version of PowerPoint. A video loop has certain advantages over the conventional animation tools. There are many animations that simply cannot be made with the animation tools only. Here you see an attempt I once made of adding an animated presentation of exhaust and air-fuel mixture to our engine using the conventional animation tools of PowerPoint. And this is actually the very best that I was able to make in spite of pretty hard work through a number of hours. Compared to this, the video loop that we just completed gives our audience a much better idea of what's actually going on inside a two-stroke engine. Ladies and gentlemen, thank you very much for your attention, and good luck whenever you embark upon making your own animations.